Good morning. Today we will study about diastereomers. What are enantiomers? What are enantiomers? What are diastereomers? How they are different? For example, let us take lactic acid. Lactic acid CH3, CHOH, COH. It consists of one asymmetric carbon atom. What is asymmetric carbon atom? A carbon atom is connected to, for example, I have shown here the Fisher projection formula. This is a carbon atom connected to four different groups. Then it is asymmetric carbon atom. That means it doesn't have any symmetry elements. Okay, now if you take the mirror image, this is in this case OH group is on the right hand side, and if you take this is considered as object, let us call this as object. Then the mirror images, and this is a DEXTRO-rotatory. For example, these are, and they are non-superimposable. As you see, they are non-superimposable. These two isomers are non-superimposable. Okay, so they are object and mirror image called enantiomers. Enantiomers. They are non-superimposable. The isomers which are related to object and mirror image and non-superimposable are called enantiomers. Okay. There are two types of stereoisomers. There are two types. I forgot to tell. There are two types of stereoisomers. One is cis-trans isomerism. Another is optical isomerism. They are called stereoisomers because they have same molecular formula but different spatial arrangement or orientation. If you look at this, they have same molecular formula but they differ in spatial arrangement. In one case, OH group is on the right hand side, in another case, the OH group is on the left hand side. These enantiomers, these optical isomers, they differ. For example, they have similar chemical and physical properties. But they differ in optical rotation. That means it will rotate the plane polarized light in the clockwise direction. It will rotate plane polarized light in the anti-clockwise direction. So, DEXTRO-rotatory. If it rotates the plane polarized light to the right, DEXTRO means right and LEVO means left. So, it rotates the plane polarized to the left. Okay, now if you have only one asymmetric carbon atom, they are called enantiomers. The isomers obtained are called enantiomers. Let us consider two. If you have two asymmetric carbon atoms, then you will have enantiomers as well as diastereomers. Then you will get diastereomers when you have more than one asymmetric carbon atom. For example, you consider this molecule 1, 2, 3, 4, 5. Okay, so 2, 3 dichloropentane. There are two asymmetric carbon atoms as is shown here. It can be represented similarly. You can represent it in the form of Fisher projection formula. Cl is right hand side and Cl is left hand side in another carbon atom. So if you consider a mirror here, then this is object and this is mirror image, and they are not superimposable. They are related by object and mirror images. 1 and 2 are called enantiomers, optical isomers. That is, one will rotate in the DEXTRO-rotatory, another will be LEVO-rotatory. Now, similarly, if you have Cl group on the same side, then if you take mirror image, then you will get 3 and 4. These are again because they are object and mirror image, and they are not superimposable because these groups are different. Therefore, they are not superimposable, and 3 and 4 are enantiomers, similar to 1 and 2. So, enantiomers we have seen. What are diastereomers? In diastereomers, for example, 1 and 3, 1 and 4, and similarly 2 and 3, 2 and 4, they are called stereoisomers. They are not related by mirror images. They are not related by object and mirror images. Diastereomers are not related by object and the mirror image. They are different. For example, 1 and 3, they are not related by mirror object and mirror images. Okay, so they are called diastereomers. Diastereomers. So there are 4 diastereomers, and now by applying a formula 2 power n, we can calculate how many stereoisomers, not diastereomers, how many stereoisomers are possible. For example, in this case, if you have only one carbon atom, and then you will have 2 power 1, therefore 2 power 1, okay, only one asymmetric carbon atom, and n is the asymmetric number of asymmetric carbon atom, then 2. Suppose you have 2 asymmetric carbon atom, then you will have 4, 1, 2, 3, 4, okay. Similarly, they ask, for example, glucose or pentose, glucose is hexose. There are 5 asymmetric carbon atoms. There are 5 asymmetric carbon atoms. The n is the asymmetric carbon atom, therefore 2 power 5 equal to 32 stereoisomers are possible. Okay, so 2 power 2, if you have 2 asymmetric carbon atoms, 1 and 2, then there are 4 stereoisomers. Now let us look at tartaric acid. Tartaric acid, it is a dicarboxylic acid, and you have OH group right hand side, OH group left hand side, and you have 1 and 2, they are stereoisomers, they are non-superimposable, they are object and mirror images, they are called enantiomers. They differ only in optical rotation, they differ in optical property only. They are chemically enantiomers, they have chemical and physical properties similar, but they differ only in optical rotation, the 1 and 2. Now another form, you will have OH on the right hand side. If you take a mirror, okay, then actually, if you have mirror here, this half is same as this, but if you have this mirror image mirror here, this half is not same as this object, and mirror image are not same, they are not superimposable. Therefore 3 and 4 are different in this case, because you have plane of symmetry. You have a plane of symmetry here. If you have a plane here, the one half is equivalent to the other half. Therefore 3 and 4 are equal. There are 3 diastereomers. Remember, for tartaric acid, there are only 3 diastereomers. Okay, they may ask you why. Because you have this, the 2 groups are similar. Here, the 2 groups are different. Okay, now, therefore, there are these 1 and 3. This is called mesoform. Mesoform is optically inactive because one rotates this carbon rotates the plane polarized to the right, and this carbon rotates the plane polarized to the left. Therefore, mesoform is optically inactive. Remember, enantiomers are optically active, whereas the mesoform is optically inactive because they have planar symmetry, and also one half is balanced by the another half. One half of rotation is nullified by the other half. So 1 and 3, you don't have 4, they are same. 1 and 3 and 2 and 3 are diastereomers. They are not related by object and mirror image. Okay, they are totally different. Therefore, they have, diastereomers have properties. If you look at the properties of, they have similar molecular formula, they have similar chemical properties. Diastereomers have similar chemical properties because they have same functional groups. They have same functional groups, OH and COH. Therefore, they have same chemical properties, but different rate. This will react at a different rate. Fast, for example, this will react fast, then this will slow, or this will react fast, this will be low, because of the difference in the activation energy barrier. For this will be different, and this will be different because of the spatial orientation. Okay, but they have exhibit similar chemical properties. But here the enantiomers have similar physical properties. But here, remember, 1 and 3 diastereomers, different physical properties. What are the physical properties? Different. All the physical properties are different. For example, solubility, boiling point, absorption, and densities, refractive index, because of molecular shape. This will be different shape and this will be different shape because of these OH group on the same side. So, and also polarity, they will have different polarity. This form will have different polarity, this form will have different polarity. But 1 and 2 have same molecular shape, same polarity, but they have, and absorption behavior is also different because OH group are on the same side. It will have different absorption behavior than this. Therefore, they can be separate because of difference in solubility. Diastereomers can be separated by fractional solubility, fractional crystallization, because of difference in boiling point. They can be separated by diastereomers can be separated by easily by boiling point, fractional distillation, and because of difference in absorption properties, diastereomers can be separated by chromatography techniques. But if you see 1 and 2, here 1 and 2, 1 and 3, this is optically active, this is optically inactive. So they have same, different optical property. But here, if you look at here 1 and 1, this is DEXTRO-rotatory, and then if you consider this as 1 and 3 are diastereomers, 1 and 3 are diastereomers, and they have same DEXTRO, they have same, they will rotate in the right claw, but specific rotation is different. It will have 30 degree means it will have 60 degree. So you can distinguish, in this case if you take this, so they differ in diastereomers differ in specific rotation by angle. More it will rotate and this will rotate less, this will rotate less maybe. So or same direction, same sign, but different, sometimes same rotation. See, same, it also clockwise, 3 also clockwise. So same optical rotation or different optical rotation. So these properties, if you understand the fundamentals, you can answer any type of questions in your NEET, JEE, and other competitive examinations. Thank you for watching.